Hi, my name is Alejandro Junior A. Kitalig, one of the reporter of TUPRE, which is Life Safety Systems and Buildings. So, bago natin tuklasin yung life safety systems and buildings, alamin muna natin ang history ng firefighting. The Roman Emperor Augustus is credited with instituting a corps of firefighting vigilance or watchmen in 24 BCE. Regulations for checking for the preventing fires were developed. The principal piece of firefighting equipment in ancient Rome and into early modern times was the bucket, passed from hand to hand to deliver water to fire. So, yun yung ginagamit or yun yung old ways ng pagpatay ng apoy. Yung from bucket of waters passed from hand to hand para maapula yung apoy. Another important firefighting tool was the axe, used to remove the fuel and prevent the spread of fire, as well as to make openings that would allow the heat and smoke to escape a burning building. So, yung axe is mahalaga rin siyang tool ng mga firefighters para malabanan yung apoy. Bakit? Dahil yung apoy is nakakapag-create siya ng mga smoke or usok na pwedeng malanghap ng isang tao na siyang magiging cause ng unconsciousness ng tao kapag nalanghap yung usok na yon. In major blazes, long hooks with ropes were used to pull down buildings in the path of an approaching fire to create fire breaks. Following the Great Fires of London in 1666, insurance companies formed fire brigades. The government was not involved until 1865 when these brigades became London's Metropolitan Fire Brigade. The first modern standards for the operations of a fire department were not established until 1830 in Edinburgh, Scotland. After the major fire in Boston in 1631, the first fire regulation in America was established. Modern fire departments are a fairly recent phenomenon developing over the past 2 centuries. Their personnel are either volunteer, non-salaried, or career salaried. Typically, volunteer firefighters are found mainly in smaller communities, career firefighters in cities. The modern fire department with salaried personnel and standardized equipment became an integral part of municipal administration only in late 1800s. So, yung firefighters is nahati sa dalawa. Yun nga yung volunteer and yung career. Yung volunteer, yun yung mga walang trabaho at nakikita siya madalas sa mga small communities. So, yun yung mga hindi nababayaran dahil nga maliit lang yung bayan na yun is walang firefighter doon, kundi sila lang. While yung mga career naman or yung mga binabayaran is nakikita sa mga cities. Dahil malaki yung population sa cities, kailangan ng mga ng, kailangan talaga yung firefighters para maapula yung apoy. And sa mga cities na yun or sa mga career na firefighters is meron silang right equipment para maapula yung mga apoy. Noteworthy building fire catastrophes. Several noteworthy fire-related catastrophes have led to sweeping changes in building codes and revised techniques used to prevent the fight fires in buildings. This event includes the following catastrophes: Iroquois Theater Fire, Triangle Shirtwaist Company Fire, Coconut Grove Nightclub Fire, World Trade Center Attack, the Station Club Fire. So first, Iroquois Theater Fire. On December 30th, 1902, fire broke out at the Iroquois Theater, Chicago, Illinois, when an arc light ignited a velvet curtain. At the time of the fire, approximately 1900s, people filled the theater to standing room only capacity. The fire resulted in over 600 deaths and was the deadliest place in Chicago history. And based on my research, Iroquois Theater Fire, bago mangyari yon is may nakita na silang fire na maliit pa lang pero pinakalma nila yung mga tao. Dahil doon is nag-cause pa rin ito ng malaking sunog at marami ang namatay dahil sa hindi gumagana yung mga fire exits sa Iroquois Theater. Triangle Shirtwaist Company Fire. On March 25, 1911, a fire broke out at the Triangle Shirtwaist Company factory on the 8th, 9th, and 10th floors of the Arch building in the Lower Manhattan Garment District of New York City. Although the fire lasted less than 30 minutes, 146 out of 500 employees at the factory were killed. So, yung Triangle Shirtwaist Company is ang karamihan na employee nila is babae. So, karamihan sa mga namatay is babae na mananahi mula sa 9th and 10th floor. Coconut Grove Nightclub Fire. A fire struck the Coconut Grove nightclub in Boston, Massachusetts on November 28, 1942. On the night of the fire, the nightclub had approximately 1,000 occupants, many of whom were military personnel preparing to go overseas of World War II. Almost half, 492 of the occupants were killed, and many more were seriously injured in less than 10 minutes. So, yung dahilan na pagkasunog sa Coconut Grove nightclub is yung electricity. Dahil hindi nakita ng electrician na may naka-open na wire doon is yun yung naging cause ng pagkasunog ng Coconut Grove nightclub. And next is World Trade Center attack. A terrorist attack catastrophically destroyed the twin towers of World Trade Center in New York City. The two towers were unable to endure the effects of direct hit by two Hyundai commercial jetliners on the morning on December 11, 2001. Shortly after the attack, both towers collapsed, killing nearly 3,000 people. So, yung World Trade Center attack is dahil sa jetline or dahil sa pagbaba ng pasabog ng mga jetlines na nag-cause ng fire sa dalawang building. At sinabi nga dito na ang nasawi sa World Trade Center attack is mahigit 3,000. The Station Nightclub Fire. On February 20, 2003, a one-story nightclub called The Station in West Warwick, Rhode Island was engulfed in flames within 3 minutes after an on-stage pyrotechnics display spread to highly combustible soundproofing foam. This led to 100 fire-related deaths and 180 injuries in a few minutes. Fire officials had inspected the nightclub 2 months prior to the tragedy. As part of the reapplications for a liquor license, after the fire, they reported that no permit had been granted to use the pyrotechnics, although fire officials reported that the club was below its occupancy limit of 300. Films of the event show that the club was crowded at the time of the fire. So, sa Station Nightclub Fire, sinabi nga rito na yung kapasidad lang ng club na ito is 300. While during that time, ito ay napuno ng higit pa sa 300 na peoples na dumalo doon. At sinasabi rin dito na hindi binigyan ng pyrotechnics approval ng gobyerno ang Station Nightclub para magsagawa ng pyrotechnics displays sa lugar na iyon. So, lumako naman tayo sa fire. So, alam natin na ang fire is a combustion reaction that requires oxygen, heat, and fuel. So, yun yung tatlong halaga para makabuo ng fire. Typically, a spark of flame ignites the fire, beginning the combustion reaction. In order for combustions to continue, there must be sufficient heat given off by reaction and a proper blend of oxygen and fuel. The rate at which fire burns is dependent on the composition of the fuel, the surface area of the fuel, the rate at which fuel absorbs heat, and the amount of oxygen that is present. So, meron nga tayong uri ng fire. which is piloted ignition temperature, and auto ignition temperature. Piloted ignition temperature. The piloted ignition temperature of a fuel is the temperature at which a fire can start when a flame or spark begins the combustion reactions. The fuel is hot enough that it releases sufficient flammable gases for combustion to occur, but a catalyst is needed to begin ignition. A large mass requires a greater rate of heating to reach the pilot ignition temperature than a small mass, such as igniting a large log opposed to a stick. Autoignition temperature, sometimes called the spontaneous ignition temperature, is the lowest temperature at which a combustible material ignites in air without a sparks or flame. Some materials do not ignite spontaneously because they break down into other substances at high temperatures and never achieve a spontaneous ignition temperature. Spontaneous combustion often occurs in piles of oily rugs, green hay, dust, leaves, or coal. It can constitute a serious fire hazard. So, progression of fire. There are four stages in the progression of fire: ignition, flame spread, flash over, and consumption. The first stage of any fire begins with the ignitions of the fuel first. These ignitions require the proper blend of oxygen or air, heat, and fuel. The second stage is flame spread, which is characteristics of rapid crawling tongues of fire that lick across the surface of walls, ceilings, floors, and supporting timbers. The natures of combustibility of the material govern the speed and intensity of flame spread. As the fire intensifies, the heated materials releases large volumes of volatile gases into air. When a mixture of gases and air reach critically proportions, the material ignites in a great ball of fire called the flashover stage. Flashover instantly consumes the surrounding oxygens and can raise the premise temperature to exceed 15 1500 degree Fahrenheit or 816 degrees Celsius. During the flashover stage, the fire might reach explosive proportions, and the final stage in the burning sequence is the fury consumptions of the material itself as it's burned to ash. The rate of destructions depend on the amount of oxygen-rich air reaching the burning area and the combustibility of the fuel ignited material. So, maritime classification of fires. Generally, fires are classified into four groups by type of fuel. Group A, ordinary combustibles such as wood, paper, plastic, trash, grass, and so on. And Group B is flammable liquids such as gasoline, oil, grease, acetone, and so on. Group C, electrical equipment. Examples of Group C is any electrical wiring, connection, equipment, and so on. And the last one is Group D, combustible metals, such as potassium, sodium, aluminum, magnesium, and so on. And the other part of life systems of the buildings is madidiscuss naman ng aking kagrupo. Yun lang. Thank you.
Hi. Hi, my name is Mark Adrian Yakat from BSc 2T, and today I'm going to discuss the continuation of 21.1. Classifications of fires. Generally, fires are classified into four groups of Group A, ordinary combustibles, example, wood, paper, plastics, trash, grass, and so on. Or Group B, flammable liquids, example are gasoline, oil, grease, acetone, and so on. For Group C, electrical equipment, for example, any electrical wiring, connection, equipment, and so on. For Group D, combustible metal, for example, are potassium, sodium, aluminum, magnesium, and so on. Extinguishing a fire. Once ignited, fires become self-sustaining as the increase in the temperature hits the fuel above its flash point. Fires must be extinguished by eliminating at least one of the constituents in the chemical reaction, namely fuel, oxygen, or heat energy. Taking away the fuel, cutting the oxygen supply, and lowering the temperature of the burning mass and surroundings are effective methods. Performance of materials in a fire. Structural collapse from high temperature is a real safety concern in buildings, as evidenced by the collapse of the World Trade Center towers after the terrorist attacks and resulting fires on September 11, 2001. The materials most commonly used in building structure assemblies are steel, wood, brick, and concrete. Their performance in a fire varies significantly. For steel, it loses half of its strength at 510 degrees Celsius. Steel is non-combustible material, yet displays a significant loss in strength at high temperatures. Next is lumber and timber. It will burn if exposed at least 150 degrees Celsius. It will burn until it is destroyed. For fired clay masonry, fired clay products are vitrified in a kiln or oven. Fired clay masonry units are relatively stable in a fire endurance test. And lastly, concrete loses half of its strength at 510 degrees Celsius. The fire endurance properties of concrete depend on the type of aggregate, the proportions of the concrete mix, and moisture content at the time of the fire exposure. Building construction types. There are five fundamental categories of building construction in the United States known as types of building construction. Each type of building construction has fire-resistive strengths and weaknesses. That is, some types burn much more readily than others. For type 1, category name, fire resistance. It is the least combustible. Non-combustible wall, ceiling, and floor assemblies, concrete masonry and protected steel walls, floors, and structural framework. Roof covering is non-combustible also. For type 2, non-combustible. Non-combustible steel or concrete walls, floors, and structural framework. Roof covering is combustible. For type 3, ordinary. Non-combustible masonry, bearing walls, but the floors, structural framework, and roof can be made of wood or another combustible material. For type 4, heavy timber. Structure consists of large solid wood timbers. For type 5, wood frame. It is the most combustible. Interior framing and exterior walls are constructed of a slender repetitive wood studs, joints, rafters, and trusses that burn very rapidly. Fire damage in buildings. Fire is one of the greatest fears of any homeowner, business owner, or director of an institution. Although the prime concern is always loss of lives in a fire, more than half of all businesses never reopen after the devastating effect of a fire. Di ba nga kapag may sabi na di bali ng manakawan, wag lang masunugan kasi kapag nanakawan kayo, may mga matitira pa. May matitirahan pa kayo. Pero kapag nasunugan kayo, mawawala lahat, ubos lahat. Walang matitira na kahit ano.
Hi, this is Simon Ian Eldridge V. Cordova, and I'm reporting for Group 3 Passive Fire Protection. Passive fire protection in buildings involves constructing walls, floors, ceilings, beams, columns, and shaft enclosures so they can resist, control, and contain the damaging effects of fire. The difference of active fire protection and passive fire protection is in the image below. Passive fire protection is intended to entail the following: Provide the structural and thermal integrity of floor, wall, ceiling assemblies during a fire for a specified time period. Com- Compartmentalize a room or space to control the fire spread. Provide the exiting systems for occupants to safely and rapidly evacuate the building. If well designed and maintained properly, passive fire protection systems are extremely effective in protecting building occupants and controlling the spread of fire. The systems require periodic inspection and necessary maintenance. Breaches in structural and thermal integrity caused by renovation can lead to the lack of proper protection in fire emergency situations. Fire resistive construction. It is a principal objective of fire resistive construction is used is to use materials and construction assemblies that contain the fire in small area and confine the fire in the room or area for a specific period of time. Fire resistive construction provides protection for a specific time period so building occupants can be made aware of the fire. The occupants can be evacuated from the building and firefighters can fight the fire. Compartmentalizing. This requires fire separation barriers on walls, floors, and ceilings for each zone of the building that serves as fire compartment. A factor that plays a great role in reducing the overall fire risk in a building is the extent to which fire-resisting construction is used to divide a building into fire-resisting compartments that will contain a fire and prevent its propagation to neighboring compartments, reducing overall fire risk. To reduce overall fire risk, fire walls are fire-rated walls that form a required barrier to restrict a spread of fire throughout the building. These firewalls are normally built of brick, concrete, or masonry. Fire separation. A fire separation is similar to a firewall except that it does not extend from the foundation to the roof assembly. Fire stop. A fire stop is a specific construction technique consisting of all materials that fill the opening around penetrating items such as cables, cable trays, conduits, ducts, and pipes, and their means of support through the wall to prevent the spread of fire. Fire protective materials. Several site-applied fire protective covering insulations and coating can be used to insulate structural members from the effects of high temperatures generated in fire. An example of this is a gypsum wall board. It's a fire protective covering that consists of approximately 21% water chemically bonded to calcium sulfate. In a fire, a large amount of energy is released to evaporate the water in the gypsum material, giving it excellent fire protective qualities. Another one is intumescent materials wells. An intumescent materials well enlarges, inflates, and expands when exposed to heat. Fire protective instrumescent coatings are applied to paint to structural steel members at a thickness that ranges from 0.03 to 0.4 in 0 or in millimeters 0.8 to 10. Intrumescent coatings expand approximately 15 to 30 times. Another one for fire protection are fire doors and windows. Fire doors are typically steel or solid wood construction and are installed with specially tested components including closers, latching hardware, and fire-rated glass. Fire-resistant glass. Fire-resistant glass can be classified in two categories, insulating and transmitting glass. Heat-transmitting glass contains flames and inflammable gas for a short period of time, but does not prevent transmission of heat to the other side of the glazing. Another thing that is used for protection is fire and smoke dampers. Another common way for fire to spread from one compartment to another is through the HVAC, the heating, ventilation, and air conditioning ductwork. Fire dampers are installed in the plane of firewall to protect these openings. Upon detection of heat, the fusible link melts, closing the fire damper blades and blocking the flame from penetrating the partition in the adjoining compartment. Smoke dampers close upon detection of smoke, preventing the circulation of air and smoke through a duct or ventilation opening. Fire and smoke dampers are controlled by a smoke or heat detector signal that is part of a fire alarm control system. Fire and smoking ratings. Several fire and smoking ratings are used to classify the behavior performance in a fire. Fire resistant ratings is a measure of fire endurance that elapsed during which a material or assembly continued to exhibit fire resistance under specified conditions. An assembly meeting the meeting the 1 hour exposure in the standard fire test receives 1 hour rating. An assembly meeting the 2 hour exposure receives a 2 hour rating, and so forth. Fire and smoke ratings. The fire resistance rating is determined in the standard fire endurance test with standard methods of fire test of building constructions and material, ASTME, American Society for Testing and Materials. This method evaluates how long construction assembly will contain a fire and how long it will retain its structural integrity during predetermined fire exposure. Fire resistance rating. Partitions required to have fire resistant ratings are rated equally from each side because a fire could develop on either side of the fire separation. Exterior walls only require a rating for fire exposure from within a building. Horizontal assemblies, floors, ceilings, and roofs are tested for fire exposure from the underside only.
Active fire protection and suppression. Active fire protection. Active fire protection system include standpipe, sprinkler, and spray system designed to extinguish the fire outright or control the fire by delaying its damaging effects. Types of fire fighting media include water, foams, inert gases, and chemical powders. Active fire protection systems are extremely effective in containing and fighting a fire if they are designed and maintained so they work properly. These systems require regular inspection, testing, and maintenance. Poor maintenance leads to a false sense of security and lack of proper protection when the system is needed under an emergency situation. Yung active fire protection, siya yung ginagamit natin pag may emergency, fire emergency. Makikita natin to sa may school, building, at kung may kayo may-ari ng bahay sa bahay din. Pero mas mainam sa bawat household sa ating bansa ay may active fire protection o extinguisher o fire extinguisher para hindi lumala ang mga apoy o sunog na nangyayari sa ating bansa. Standpipe system. A standpipe system is an internal piping network connected to the fire hose stations. Firefighters can use hoses connected to standpipe systems or connect their hoses to valve outlets near the fire. Standpipe systems are used in buildings where it is difficult for the fire department to adequately pump water on the fire to adequately fire it. A standpipe also provides water that trained occupants or employees can manually discharge through hoses. Standpipes running vertically are usually called risers. The maximum length of a single hose line is 125 feet. The hose outlets are located so that every part of the building may be reached with the hose streams. The nozzle is used to direct the stream of water from the hose. The occupant or firefighter must manually open the gate valve to open flow to the hose, and the hose is connected to a point at the end of the nozzle. The standpipe is usually stored on a quick-release rack called a hose wheel, but it can be labeled fire hose. This is example of fire hose. Ito yung closed tapos yun yung connected. Types of standpipe system. Wet pipe system is the most commonly used standpipe system. It is used in heated buildings where there is no danger of the water in the piping freezing. In some cases, a fire pump may be used to increase the water pressure in the system. Next, dry standpipe with an automatic dry pipe valve. It's designed to open when there is a drop of air pressure in the standpipe. When a hose is open, it causes a drop in air pressure. Then the dry pipe valve automatically lets water flow into the standpipes. The valve should be kept open at all times to supply the standpipe system. The system is usually installed in a building that is not heated. Dry standpipe with a manual control valve. This system is supplied by a public water main. Under normal conditions, this system has no water in the piping. The water is not allowed into the standpipe until a control valve is manually operated. The control valve remains closed until a fire occurs. This system is usually used in a building that is not heated. Next, dry standpipe with no permanent water supply. Under normal conditions, this system has no water in the piping. Water is pumped into the standpipe system by the local fire department. A sign must be attached to each of the hose outlets. This system is usually used in a building that is not heated. Classes of standpipe system. Standpipe systems are classified depending on who is expected to use the system. The three classes are briefly described in the following. Class 1. This system is designed for use by professional firefighters. For example, fire department personnel use the system. The fire hoses in this system are 21/2 inches in diameter. The larger hose diameter makes it difficult to control the stream of water from the hose. Class 2. This system is designed for use by the occupants of a building. The hose and nozzle are connected to the standpipe. They are ready to be used by occupants in case of a fire. The hose is 11/2 inches in diameter. The hose stream is easier to control than the Class 1 hose. Class 3. These systems may be used by either professional firefighters or by occupants of the building. The hose seam may be adjusted to either 11/2 or 21/2 inches in diameter. Attaching special reducing valves to the hose lines does this. Automatic fire protection system. Automatic fire suppression systems are intended to extinguish or control a fire. These include automatic water sprinkler systems and systems that use a gas agent or foam to eliminate oxygen and suffocate the fire. Smoke control systems are designed to limit the spread of smoke to maintain possible occupant egress routes and to aid firefighters in fighting the fire, among other things. The fire control panel sounds an alarm, shutdowns air handling equipment, disconnect power from the protected equipment, and then releases agents into the protected area. Conventional automatic sprinkler system. An automatic sprinkler system consists of the sprinkler heads and a network of pipes placed in a horizontal pattern near the ceiling. The system is designed to extinguish the fire entirely or to prevent the spread of the fire. When the sprinkler heads open, they are said to have fuse. If more than one head opens, they are sprayed by each overlaps that of the sprinkler head next to it. An approved automatic sprinkler system is installed in accordance with fire or building codes. It uses the proper framework and equipment for the structure of occupancy and construction. Yan. Ito yung wet pipe sprinkler control with pressurized water, the pipe and mate. Yan mga example nila. Yan pa. Next is types of conventional automatic sprinkler system. There are several types of automatic sprinkler fire suppression system. The following are the conventional types. Wet pipe automatic sprinkler system. Wet pipe automatic sprinkler system have pressured water in the pipe and mains. Water is released when the sprinkler head is activated. This type of system is used in locations subject to freezing. The antifreeze solution swallowed by water discharges when sprinkler heads open by a fire. Use of antifreeze solution is limited because they are costly and difficult to maintain. Dry pipe automatic sprinkler system. The dry pipe typically is used in unheated buildings where there is danger that the water in the pipes will freeze and burst the pipe. When a sprinkler head is activated, the air will begin to release and the air pressure will drop. The pressure difference is what kept the water off the sprinkler lines. Pre-action automatic sprinkler system. Pre-action sprinkler systems are similar to dry pipe. Water is stopped at feeders by a valve. Water will then flow to all heads, but will only discharge through the activated heads. If there is an accidental break of a sprinkler line, water will not immediately discharge because the valve is holding back the water flow. The pre-action sprinklers are often used where the use of a sprinkler could cause extensive material or equipment damage. The large automatic sprinkler system. The large automatic sprinkler system allow all sprinkler heads to go off at the same time. The large systems are generally installed in hazardous areas. Once a heat detecting device activates the valve, water will flow from all heads. A drawing of a wet pipe sprinkler system. Ito yung example niya. Next, automatic sprinklers. Automatic sprinklers are devices that open automatically to charge water when an excessive temperature is detected. Sprinkler heads are made of a metal alloy with a fixed melting point. When the disk reaches a temperature of 160 Fahrenheit, a valve opens permitting water to flow. When it cools, the valve closes to shut off the water. The latest type of sprinkler head is called the cycling sprinkler, which cycles water on and off depending on the temperature. The system works immediately upon sensing excessive temperature to prevent the fast developing fires of intense heat, which can trap and kill building occupants. The water from the sprinkler pipes flows directly over the source of the heat. Ito yung example ng water discharging from a sprinkler head sprays over a wide area. Distribution of the spray depends on sprinkler head height and design. Ito pa yung mga example nila. Sprinkles with red or orange glass bulb have a proprietary light hazard classification. Sprinkler heads exposed to corrosive conditions are often covered with a protective coat of wax or lead. Care must be taken to ensure that the protective coating is not damaged when handling or replacing the heads. They can damage, weaken, or destroy the delicate parts of the sprinkler heads. Corrosive vapors can also seriously block the spray nozzles in the sprinkler head. The sprinkler head must be carefully monitored for signs of corrosion to prevent damage to the glass of metal. The bulb that will expand with temperature increase, causing the bulb to shatter and the sprinkler to activate is called a sprinkler. Sprinkler operation and layout. A sprinkler system are installed in accordance with building and fire codes. Once activated, conventional sprinklers continue to run until the main valve is manually closed. This can result in excessive water damage, one of the major causes of property loss in fire. The sprinkler must be replaced after they have been replaced. A network of pipe delivers water to the sprinkler heads and the entire system is exposed to the view in warehouses and retrofitting buildings. The most commonly used sprinklers are often used in small rooms where they can throw a spray of water across the entire room. The U.S. Department of Health and Human Services recommends the sprinkler be placed on the roof of the building with at least one sprinkler head per room. Types of pipe approved for use include the following. Steel pipe are approved for use in all fire suppression. Sprinkler application is available in the following nominal diameters: 3 over 8, 1 half, 3 fourth, 1, 11 over 4, 11 over 2, 2, 21 over 2, 3, 31 over 2, 4, 5, 6, 8, 10, and 12 inches. Threaded and flank connections are used to join and fittings, especially compression straight fittings called Victorlic couplings make system installation easier. Copper tubing is the most popular water supply pipe material but is used less frequently in sprinkler system. The thin walls of copper tubing are usually soldered to the fitting is available to the following nominal diameters here. Chlorinated olivinium chloride or CPVC is a rigid plastic pipe generally approved for use in fire suppression sprinkler system, is residential and many light commercial applications. It is available in straight lengths in the following nominal diameters here. Solvent, cement, welding, threaded, and flank connection are used to join CPVC pipe and fittings. CPVC pipe and fittings for fire sprinkler system are no orange in color. Alarm and control valves. An alarm valve and gate valve serve to control in the networks of sprinkler system. Large building must be protected by multiple sprinkler systems, each having an alarm system. The alarm valve must be functioning in order for the system to work. The gate valve should be maintained in the open position at all times. It should be in the locked position for safety reasons. Primary source of water supply. Water for automatic sprinkler and standpipe system must be available in sufficient quantity and at a sufficient volume and pressure at all times to ensure reliable operation in the event of fire. Potential sources of water supply include a direct connection to the public water supply system, gravity tank, pressure tank, or automatic fire pump. Water in the tank is distributed throughout the sprinkler or standpipe system by the force of gravity. A fire pump is a part of the fire sprinkler system water supply in high-rise installations where the local public water system cannot provide sufficient pressure. The pump is designed to pump water into the fire suppression system under high pressure to supply it with a safe level of water. It is connected to the water supply piping or static water sources to supply water to sprinkler system in tall buildings. Ito yung approximate water application rates for various manual and automatic suppression methods compiled for various industry sources. This is the example. Kayo na yung magbasa. Thank you for listening. God bless everyone and keep safe.
Hi, my name is Gerard Mancipi Munoz of BSc 2D, and I'm going to report active fire protection and suppression. First one is supplementary sources of water supply. Supplementary sources of water supply for sprinkler and standpipe systems include manually or automatically activated fire pumps or Siamese connections. Siamese connections is a Y-shaped inlet connection for fire department used in supplementing or supplying water for standpipes and sprinkler systems. And these are the photos for the supplementary sources of water supply. The next one is backflow and backflow prevention. Poor water quality is found in most fire sprinkler systems because of stagnation of water and contamination from cross connections that typically occur in a fire. For example, most fire sprinkler systems are constructed with piping material that is not approved for potable water. Fire sprinkler systems must have backflow prevention capabilities installed to protect the public or private potable water distribution systems from backflow water. The backflow prevention method required is dependent upon the hazard level or classification of the fire protection system. Typically, a double check valve assembly or DCVA or a reduced pressure backflow prevention assembly or RBPA is required in residential, commercial, and industrial installations. Alternative fire suppression systems. Conventional sprinkler demand high water supply rates and are associated with fixed large diameter pipe networks around the area to be protected. The necessity for large amounts of water has some inherent disadvantages. It damages most of the building's contents and interior finishes. Flammable oils tend to float on the water surface and continue to burn. It conducts electricity, and if it vaporizes into steam, it may be harmful to the firefighters. Other methods may be considered when these disadvantages are of major concern. These alternative methods include the following. The first one is water mist automatic sprinkler systems. Water mist automatic sprinkler systems rely upon a fine spray of water to suppress a fire. A typical system consists of cylinders of water under pressure, heat or smoke detectors, and discharge nozzles connected to a network of pipes. The ability of small droplets to absorb heat, and create steam at the fire source is the key to the effectiveness of fine mist systems in controlling and extinguishing fires. This process makes water mist systems more effective than a conventional automatic sprinkler system. But like conventional systems, water mist systems cannot be used on water-reactive materials. When compared to conventional automatic sprinkler systems, the amount of water required in a water mist system is significantly less. Only very small amounts of water and air are needed to extinguish even the most intense fire, including gasoline fires, because a small amount of water is effectively spread into fine water droplets covering a large area. The second one is clean agent gas fire suppression systems. Clean agent gas fire suppression systems discharge as a gas on the surface of combusting materials. A typical system consists of cylinders of a liquid agent under high pressure, heat or smoke detectors, and discharge nozzles connected to a network of pipes. Uh, Halogenated hydrocarbons known as halogens have been used in clean agent gas fire suppression systems for decades. The most commonly used agent was Halon 1301, an inert gas. However, because of its damaging effect on the Earth's ozone layer, production of Halon 1301 ceased on January 1, 1994. Halon alternatives include FM200R, or called heptafluoropropane, Energen R, a mixture of three gases, approximately 52% nitrogen, 40% argon, and 8% carbon, and Fe13R, or called trifluoromethane. These are environmentally friendly with no ozone depletion, no global warming potential, and zero atmospheric lifetime. And this is the sketch of a clean agent gas fire suppression system. Carbon dioxide fire suppressing systems. Carbon dioxide fire suppression systems discharge the CO2 gas that extinguishes fire by displacing oxygen or taking oxygen away from the fire. CO2 is also very cold as it comes out of the extinguisher, so it also cools the fuel. A typical system consists of cylinders of liquid CO2 under high pressure, heat or smoke detectors, and discharge nozzles connected to a network of pipes. CO2 systems have been an industry standard for many decades and are still the preferred agent in many confined space or tank applications. The principal problem with CO2 is that it must be used in fairly high concentrations, and because high CO2 concentrations deplete much of the oxygen in a space, this type of system cannot be used with occupants or other living beings present. As a result, it is usually used in confined areas such as mechanical chases, unventilated areas, and display cases. There are several common application systems that utilize CO2 to extinguish fires in engine compartment, deep tanks and quench tanks, and operation where spilled fuel is a possibility. The next one is foam fire suppression systems. Foam fire suppression systems discharge a high volume of gas-filled bubbles that rapidly fill a space. Foam masses are lighter than water and flammable liquids, and they may be either air or chemical gas bubbles. They float on the surface of burning liquids to deplete oxygen and smother the fire. Automatic sprinkler testing and maintenance. After installation of an active fire protection system is completed and approved, fire codes generally require a certificate from the contractor indicating that the system was installed in compliance with the code and that all of the required tests were performed. The contractor issuing the certificate must be licensed in installation of fire protection systems. Systems are typically hydrostatically tested at a pressure of at least 200 psi, which is well above street pressure. Active fire protection systems must be well maintained to ensure reliability. In particular, systems using water and water-based foam are prone to rust deposits that can obstruct sprinkler heads and spray nozzles. Periodic testing and maintenance is essential to ensuring that the fire protection system will work as intended in a fire situation. And this is the image of a pressure test of a sprinkler system. The next one is influence on building design. The presence of an automatic fire sprinkler system or smoke control installation influences the allowable size and configuration of a building because it extends the distance an occupant can travel when exiting the building. Typically, the maximum distance of travel from any point to an exterior exit door, horizontal exit, exit passageway, or an enclosed stairway in a facility, building, or structure not equipped with an automatic fire sprinkler system should not exceed 150 feet. This distance is extended 200 feet in a facility, building, or structure equipped with an automatic fire sprinkler system installation throughout. Automatic sprinkler systems in residences. Automatic sprinkler systems installed in a single-family residences are simplified version of the systems introduced earlier. Usually, a variation of the wet pipe system, a residential sprinkler system typically uses a one-half in orifice. Standard sprinkler with a maximum of 256 feet squared coverage and a 25 GPM flow rate. If the system is not supplied by an adequate public water source, a 250 gallons stored water supply is required to provide a 10-minute water supply. Sprinklers are required in living rooms, bedrooms, or kitchen areas, but not required in bathrooms 40 feet squared or less, small closets for 24 feet squared or less, attics not used as a living space, porches, carports, and garages and foyers. A multi-purpose residential fire sprinkler system combines the domestic potable cold water system with the residential fire sprinkler systems. It uses the cold water piping to serve as a supply for both the domestic fixtures and the fire sprinklers. Portable fire extinguishers. Portable fire extinguishers can be used to put out most fires in their early stages. They are classified according to their ability to handle specific classes and sizes of fires. Not all fuels are the same, and if a fire extinguisher is used on the wrong type of fuel, it can make matters worse. Labels on extinguishers indicate the class and the relative size of fire that they can be expected to handle. And this is the photo of a clearly marked fire extinguisher in a cabinet. There are four types of portable fire extinguishers. The first one is Class A extinguishers. Class A extinguishers are suitable for use on fires in ordinary combustibles such as wood, paper, rubber, trash, and many plastics, where a quenching cooling effect is required. The numeral indicates the relative fire extinguishing effectiveness of each unit. Class A extinguishers are rated from 1A to 40A. Extinguishers rated for Class A hazards are water, foam, and multipurpose dry chemical types. The second one is Class B extinguishers. Class B extinguishers are suitable for use on fires in flammable liquids, gases, and greases, where an oxygen exclusion or flame interruption effect is essential. Class B extinguishers are rated from 1B to 640B. Extinguishers rated for Class B hazards are foam, halon alternative, and CO2, and multipurpose dry chemical. The third one is Class C extinguishers. Class C extinguishers are suitable for use on fires involving energized electrical equipment and wiring where the dielectric conductivity of the extinguishing agent is of importance. For example, water solution extinguishers cannot be used on electrical fires because water conducts electricity, and the operator could receive a shock from energized electrical equipment via the water. Class D extinguishers. Class D extinguishers are suitable for use on fires in combustible metals such as magnesium, titanium, zirconium, sodium, and potassium. No numeral is used for Class D extinguishers. The relative effectiveness of these extinguishers for use on specific combustible metal fires is detailed on the extinguisher nameplate. Air pressurized water fire extinguishers. Air pressurized water extinguishers are large silver tanks filled about two-thirds water and then pressurized with air. An APW is a giant squirt gun that stands about 2 feet tall and weighs approximately 25 pounds when full. They are designed for Class A fires only. Carbon dioxide fire extinguishers. Carbon dioxide fire extinguishers are filled with non-flammable carbon dioxide gas under extreme pressure. They are designed for Class B and C fires only. CO2 is a gas that extinguishes fire by displacing oxygen. CO2 is also very cold as it comes out of the extinguisher. So it also cools the fuel. CO2 may be ineffective at extinguishing Class A fires because they may not be able to displace enough oxygen to successfully put the fire out. Burning materials may smolder and reignite. CO2 extinguishers are used in laboratories, mechanical rooms, kitchen, and flammable liquid storage areas. CO2 extinguishers are filled with non-flammable CO2 gas under extreme pressure. A CO2 extinguisher can be recognized by its hard horn and lack of pressure gauge. CO2 cylinders are red and range in size from 5 pounds to 100 pounds or larger. In the larger sizes, the hard horn will be located on the end of a long flexible hose. Dry chemical fire extinguishers. Dry chemical fire extinguishers put out fire by coating the fuel with a thin layer of dust separating the fuel from oxygen in the air. The powder also works to interrupt the fire reaction of fire, the chemical reaction of fire. So these extinguishers are extremely effective at putting out fire. Dry chemical extinguishers come in a variety of types. ABC indicates that they are designed to extinguish Class A, B, and C fires. BC indicates that they are designed to extinguish Class B and C fires. Class ABC fire extinguishers are considered multipurpose. They are usually filled with ammonium phosphate. They are not ideal for electrical fires because they leave a hard residue that is difficult to remove. Class ABC fire extinguishers are found in a variety of locations. New buildings will have them located in public hallways. They may also be found in laboratories, mechanical rooms, break rooms, chemical storage areas, offices, and vehicles. ABC extinguishers are red and typically red in size from 5 pounds to 20 pounds. Class BC extinguishers may be located in places such as commercial kitchens or areas with flammable liquids. Fire extinguisher location. Portable fire extinguishers must be strategically situated. They must be located so the travel distance is not more than 75 feet for Class A and Class D hazard areas, and not more than 50 feet for Class B hazard areas. Extinguishers must be located close to the likely hazards, but not so close that they would be damaged or isolated by the fire. If possible, they should be located along normal paths of egress from the building, where highly combustible material is stored in small rooms or enclosed space. Extinguishers should be located outside the door and never inside where they might become inaccessible. Extinguishers must not be blocked or hidden by stock, material, or machines. They should be located or hung where they will not be damaged by trucks, cranes, and harmful operations, or corroded by chemical processes and where they will not obstruct aisles or injure passers-by. All extinguishers locations should be made conspicuous. For example, if an extinguisher is hung on a large column or post, a distinguishing red band can be painted around the post. Also, large signs can be posted directing attention to extinguishers. Extinguishers should be kept clean and should not be painted in any way that would camouflage them or obscure labels and markings. Smoke control systems. Smoke can cause significant damage to interior spaces and equipment. For example, smoke can corrode electronic equipment, such as printed circuit boards found in computers. By the time heat accumulates at the ceiling and activates heat detectors or sprinkler heads, smoke could have already done damage. As a result, smoke detectors are recommended in spaces containing electronic equipment such as computer rooms and sound booths. A smoke control system is an engineered system that uses mechanical fans to produce airflows and pressure differences across smoke barriers to limit and direct smoke movement. It is the part of a fire protection system that manages and directs smoke to protect building occupants and property. This system can also be used to assist firefighting activities. That's all for the topic of active fire suppression and protection. Thank you and God bless.
Hi, my name is John Corbugarin and I'm discussing Lesson 2.5 Building Securities. Things to consider in building security. First, initial building design. Security issues in a building should be considered in the early planning and architectural design stages. This will simplify the ensuing security system design, decrease security costs, and reduce the potential for crimes to occur in the building or building complex. So sabi dito, bago itayo yung building, kailangan sa design pa lang ng mga architect, meron ng security system design para ma-reduce or mabawasan yung potential na magkaroon ng isang crime sa iyong building. Second is material selections. Doors, windows, and their hardware should be carefully selected to be certain that they will discourage intrusions. Windows should be designed so that the glass cannot be removed from the outside, and the hardware should be such that the window cannot be opened from the outside with a plastic guard. So, pangalawa, kailangan i- i-select yung material na magaganda tulad sa doors and windows. Sa doors, kailangan um, metal para hindi madaling mapasok. Sa window naman, kailangan hindi siya nare-remove outside. So, third natin, building security system. A basic electronic security system consists of a control panel, keypad, digital communicator, backup battery, transformer, sensing device, and a horn, buzzer, or siren. So, sa building security system, ito yung maglalagay ka ng mga alarms, ng mga backup battery, transformer, sensing device, yung mga CCTVs, mga mga sensors sa door, sa window, yung mga yun. So, third is perimeter protection. The first level of protection for any security system is perimeter protection. Perimeter protection includes such areas such as doors, windows. It may also include closed-circuit TV video surveillance. So, for the word itself, perimeter, nakapaligid sa building mo, yun yung first level ng protection mo. And yung mga first level of protection mo, ito yung mga TV video surveillance tulad ng mga CCTVs. Yan. And next one. Oh, sobra. Interior protection. Interior protections provide a backup to perimeter protection. These include infrared, IR, motion detectors, glass break detectors, floor mat detectors, emergency immediate response keys. So, itong interior protection, ito lang ay isang backup ng perimeter protection. So, sa interior protection, meron tayo infrared IR motion detectors. Ito yung masesense yung mga tao, matao, yung mga temperature, ganon. Tapos sa glass break detectors, ito yung mga detectors na pag may nabasag na glass, mag-a-alarm. Sa floor mat naman, yung pag may nakahapak sa mat, mag-a-alarm, ganon. Sa emergency immediate response keys, Yon pag may emergency, malalaman ng mga nandun sa control panel. So next is video and audio surveillance. Surveillance systems can record activities. Recorder playback functions can be used to review a past incidents and assist police in catching the perpetrators of a crime. So video and audio surveillance, ito yung mga CCTVs. So di ba, pag may crime na nangyari, unang tinitignan yung mga surveillance systems, yung mga naka-record para ma-help yung mga police na mahuli or ma-identify kung sino yung mga kriminal. Next is alarm. The alarm set off by the fire system may be a bell inside and or outside the building, a bell inside and a horn outside, a horn inside and or outside, or a horn with a light or beacon. So itong mga alarms, kailangan to kasi pag merong let's say lindol, sunog, para ma-alarm yung mga taong nasa loob, yung mga nagtatrabaho sa loob na merong disaster na nagaganap. So yung ibang mga alarms merong mga light yon kasi pag minsan mawawalan ng light sa isang building, yung mga alarms kailangan nila ng light para mag-guide yung mga tao, makakita yung tao. So next, electronic access control system. Many large companies use electronic access control systems to control employee entrance by identifying an authorized individual and allowing that person access to a secret area. Access control can deny an unauthorized employer or outsider access into a restricted building or space. So itong electronic access control system, ito yung system na ginagamit ng mga large companies para makontrol yung pagpasok ng mga employee. So, isang magandang halimbawa sa ano na to is yung card, yung binibip lang yung card para makapasok sila sa entrance. Isa pa yung photo ID. Yan, yung basta pag na-scan yung identity mo, pwede kang pumasok sa building. So, yun yung electronic access control system. Security personnel. Security guards are personnel that provide security in many buildings by serving as a physical presence that tends to deter crime and improper activities. So, alam naman natin lahat na ang building ay may security guards. Yung mga pawn shop, SM, mga ganun. And mahalaga tong mga security na to para syempre pag mayroong security, hindi naman agad mananakawan yun, hindi naman agad susubukin ng ano yun, ng mga kriminal. So, next is emergency power systems. Emergency power is the electricity that is generated locally on a limited basis for the purpose of supplying electricity to a critical device during a general power outage. So, mahalaga itong emergency power system. Kasi halimbawa, nag nawalan ng kuryente, meron kayong emergency power para magamit yung lights. Halimbawa, diba, lumindol, nawalan ng kuryente, nawala yung mga lights. Meron kayong backup power system para ma-on yung lights at para ma-guide yung mga tao na lumabas ng building. So, next is emergency lighting. So, emergency lights enable building occupants to safely escape the building. In the event of power failure, equipped with batteries, those lights are capable of powering exit and emergency lights for more than an hour. So, ito yung sinasabi ko kanina, pag merong disaster na nag-occur, pag nawalan ng kuryente, meron tayong emergency lights. And mahalaga yon para yung mga tao sa isang building ay makalabas o maka-escape sa building ng safe. So, ito yung pinaka-last and ito ay mahalaga. Emergency Action Planning. A building emergency action BEA plan provides for immediate, positive, and orderly action to safeguard life and property in the event of emergency or disaster, except enemy attack. The BEA plan should address emergency that employer may reasonably expect in the workplace. Itong emergency action planning, ito yung merong taong mga taong nag-aano dyan sa emergency action planning, mga nagpa-plan. So, mahalaga to kasi kapag merong disaster na nag-occur at nagpanic na yung tao, merong mga action na kailangan gawin, merong plano para maka-escape sa building, makalabas ng building, na lahat maging safe. So, yun lang po yung discussion ko. Thank you so much.